Assalamualaikum warahmatullahi wabarakatuh. Good morning, good afternoon, and good evening for everyone who is watching this video. My name is Mitchel Mohamad Affandi, and I'm from Group 1 along with my teammates Hilmy Baihaqi and Bagas Maharda Wisesa. We would like to present our calculation with a final test project of the subject probability and statistics. So without further ado, let's just jump right into our discussion. So first of all, as a premise, we were given a set of data from our lectures, and this data is about the midterm and final term tests from 42 different individuals in a class. As you can see here, we have random numbers put on the tables, and there are 42 data inside of it. So what we have done with this data is that we've processed the data to search for the central tendency measurement, and then we also search for the variation measurement, and also we plot this data on the stem plot and box plot, and finally we also search for its linear regression equation in order for then we're going to be able to predict two predictions of, for example, if let's say a person has X as a result of their midterm test, so what will be the result of his uh, final term test, and to see whether there is any correlation between the midterm test and the final term test. So let's just first get into the central tendency measurement. As you can see here, before we actually able to calculate the central tendency measurement, the first thing that we have to do is to order the data or to sort the data in order. As you can see here, we have the midterm and the final term data ordered according to uh, ascending manner, which starts from the smallest and ends with the largest. And after we have ordered the data, we then can continue into our calculation. So first, we have to calculate the mean. What is the mean actually? So the mean is basically the average of a data set. So the average is calculated from summing up all of the value that is available on the data and then dividing it by the number of how many datas there are available. So for the midterm tests, we actually got the average of 56.44, and for the final test, we got the average of 46.9. And then we also calculate the modes. So what is the modes actually? The modes is the most frequent data that appeared on the data set. So for the midterm table, we got 0 as the most frequent number that appeared, and it appeared for 4 times. And for the final test, we got also 0, which appeared for 5 times. And after that, here's where the ordered set of data actually comes into handy. When we're trying to calculate the quartiles, the first thing that we have to do is to determine the position of each quartiles. For Q2, it's actually quite straightforward because Q2 is actually the median of a data set. So Q2 is just, for example, if you have a data set and you divide it by 2, and the position of where it is exactly divided by 2, that is the position of the median or the Q2. But for Q1, we have to first determine the position. So here, for the midterm test, I have actually determined the position for each Q1, Q2, and Q3. So Q1, using the formula, which is the formula for searching the quartiles, which is the position of the Q. For example, if you're trying to calculate Q1, then you use 1 times n, which is the number of data that is available, plus 1 divided by 4. And for the Q2, you use 2 times n plus 1 divided by 4. And for Q3, you use 3 plus n plus 1 times n plus 1 divided by 4. And that is how you can determine the position of each quartiles. So back to our presentation. Here we have the Q1 position is at 10.75, and the Q2 position is at 21.5, and the Q3 position is at 32.25. And from here, we can then go back into the order data to search for the exact position of where a value lies on this calculated position for each quartile. So for example, for the midterm for the Q1, we have it at 10.75. So we then have to search for the 10th data, which is 27, and then use the decimal value, which is 0.75, to multiply it using the subtraction of the 11th data and the 10th data, which is 27. So the 11th data is 29, and then 29 minus 27 multiplied by 0.75, which is the decimal value of the position. And summing that with 27, we got the Q1 exact value, which is 28.5. And that's how we can calculate the quartiles. And after the same calculation, we can get Q2 is 61 and Q3 is 82.125. And for the final test, we got the Q1 37, the Q2 50, and the Q3 70. And finally, we're going to calculate the mid-range and the mid-hinge. So mid-range is just the smallest data uh, plus the largest data divided by 2. So for the midterm, we got it 49, and for the final term, we got it 48. And for mid-hinge is the quartile, the lower quartile with the upper quartile being summed up together and then divided by 2. So for the midterm data, we got it around 55.31. And for the final term, we got the mid-hinge is 53.5. And after that, we're going to continue to variation measurement. This measurement will then be used to calculate the box plot, which will be explained by my friend. But for now, let's just check out what we have here. So first, we have to calculate the range of the data. So it's just quite straightforward. For the range itself, we just have to calculate the largest data, subtract by the smallest data. So for the midterm, we got the range is 98. And for the final term, we got it 96. And then we have to calculate the IQR, which is the interquartile range. The interquartile range is just the Q3 subtract by the Q1. So for the midterm, we got 81.125 subtract by 28.5. We got the value of the IQR, which is equal to 53.625. And then for the final term, same thing happened. So 70, which is the Q3, subtract by 37, which is the Q1, we got 33 as a result. And then we have to calculate the SIQR, which is the semi-IQR. Now, semi-IQR, it's just IQR divided by 2. So we already calculated for the midterm, which is 53.625. We then divided by 2. We got 26.81. And then for the final term, we just have to divide 33 by 2. And then we will have 16.5. And then we also calculate the variance of both data. So for the midterm, this is the formula that we use. So we first have to subtract each of the element inside of the table using the mean, and then we will use that value to square each of them. And finally, all of them will be summed up and divided by the amount of data minus 1. As you can see here, this is the formula. So s squared, which is variance, is equal to the sum of each element minus the mean squared divided by n minus 1. And we have the value for the midterm, which is equal to 979.0634. And for the final term, we got it around 767.735954. And that is for the variance. Lastly, we have to also calculate the standard deviation. And the standard deviation, it's just s. So we already have s squared, and we only need to root that s squared. So the root of s squared is obviously s. So for the midterm, we have the s, or the standard deviation, is equal to 31.289, and then the final term is equal to 27.70805. And that is for the calculation. So for the stem plot and the box plot will be continued by my friend. See you on another place. Goodbye.
Next, we move to stem plot and box plot calculation. First of all, what is a stem plot is? A stem plot or stem and leaf plot is a data visualization method used to display the distribution of numerical value quickly and simply. The data is divided into two parts. The first one is the stem, which contains the leading digits, and the second one is the leaf, which shows the last digit of each value. The purpose of making a stem plot is making it easy to see the shape of the data and individual value. This is our calculation. After we sort the data one by one, it can be written like this. The midterm exam stem plot shows a leaf skew or negative skew distribution, while the final exam stem plot shows a symmetrical distribution. Next, what is a box plot is? A box plot or box and whisker plot is a statistical graph that summarizes data based on 5 key values: minimum, first quartile, median, third quartile, and maximum. The diagram consists of a box with a line, or whisker, that represents the range of the data. Box plots are helpful for identifying outliers and visualizing the spread and symmetry of the data. There are several steps before we draw a box plot. We need to find the value of one step, two steps, lower outer fence, lower inner fence, upper outer fence, and upper inner face. After we calculate one by one from the formula, we have the value for one step is 80.4375, two step is 160.875, for inner outer fence is 162.5625, for upper outer fence is 243, for lower inner fence is 51.9375, for lower outer fence is minus 132.375. After we know the value of each function, we can draw the box plot like this. Because the x-min or x-max value are not every fence, there are no outliers for the data UTS. Same like UTS box plot, UAS box plot also has no outliers because the x-min or x-max value are not in every fence.
Okay, for now, we got also the box plot for ORS block plot or final test of block plot. Maybe it's the function is same like that Hilmy say in the previous slide, but maybe I will explain from that the value for the UAS box plot is quite different from the UTS box plot. That x min we got 0, and then x max we got 96, and then for the n it's still 42. Yeah, and then key 1 we got 37, key 2 50, and key 3 is 70. That we can see that in the previous slide it's quite different for the value. And then for the IQR we got the 33, one step we got the 49.5, and then two step we get the 99. And for the UIF we got the 119.5, and then the UOF we got the 169, and then the LIF we got the minus 12.5, and then the LOF we got the minus 62. And then this is the graph, or this is the stem plot. And then we go to the next slide, that we get into the simple linear regression. So after that we go into the simple linear regression. So basically what that we search in this topic, that we search for the regression equation. So what is regression equation? So basically regression equation is a mathematical formula that have models the relationship between the one or more independent variables or predictors, and then the dependent variable or the response. Maybe it commonly used in statistic that we learn right now, and then the machine learning to predict or explain the value of the dependent variable based on the independent variables. Okay, so we go to the equation. The first one, as you can see, we get the formula that this is for search of beta. And then I explain first. We have the y, or the dependent variables. It is the one you want to predict or explain. And then we have the x, or the independent of variable, the predictor or explanator variable. So the first one, as you can see, in the first step, you got the beta equation or beta formula, that the n is the total number of data point, and then the x is individual values of the independent variable, and then the y is individual values of the dependent variable of y. So basically we are putting all the data that we searched previously to this formula, that n is equal to, and then it's been summation of x and y and their combination, and then the result we get for this, the first equation is 0.186433. And then we go into the second formula, that this is search for the alpha, the intercept of alpha. We're using the alpha is equal y minus beta x. So basically this y is independent variable, and then the x is independent variable. Also the beta is for the slope calculated earlier. And then we go to the values, that y we got the 46.90, and then the beta we got the 0.186433 from the previous one that we calculate, and then the x we got the minus 56.44, and then we substitute into the formula. The 46.90 is minus of minus 0.186433 times 56.44, and then we got the 46.90 plus 10.525222785, and then we got the equal is 57.44222782. And then we go to the final regression equation, or the final formula that we use for search y. The formula says is y equals alpha plus beta x. So in this photo, we want to see and search for the y, because we have both alpha for the intercept and the beta for the slope. And then we just input the formula. We just input the data that we use, that 57.42227852 minus 0.186433, and then the equal we get the 57.42 minus 0.186 x. Okay, for the next one, we go into the regression line. So basically what is regression line means that regression line is a straight line that represents the best fit relationship between the a dependent variable of y and then the independent variable of x in the dataset. It used to predict or explain the value of y and then based on x. Okay, so from the illustrate that graph that we get in this PowerPoint, we can say that the blue points of the x cross is represent an individual data point where the UTS score or x-axis and the corresponding y score y-axis are plot. Maybe I can say this point is show the raw data distribute on the relationship between the two variables. So in the second one, we got the red line or the regression line. So the red line is the best fit line generated by the linear regression model, and we can see that we have the equation is give like y is equal 57.42 minus 0.186x. So basically the 57.42 is the intercept, meaning that it's predict y score when the UTS score is 0, and then the minus 0.186 is the slope, indicating that for every 1 unit increase in this UTS score, the y score is decreased by 0.186 on average. So maybe I will explain again for the relation between variables. Okay, so the slope of the regression line is negative, which is suggests a negative correlation between UTS and y score. As a UTS score or x increase, and then the y score or y is tend to decrease slightly. So next in for the interpretation, that the model attempts to predict y score based on UTS score, but maybe we can say the data points are widely scattered around the regression line. So this is indicates that the linear relation between the two variables is weak, suggesting that other factors beyond the UTS score might significantly influence y score. Okay, so we go to the next step to search the prediction of true problems in the simple linear regression. Okay, so as we can see, there is two probability in this step, and then we can say that the first one we search for the y score mean while the UTS grade is 10. So if a student grade in the UTS or the midterm is 10, by the UAS grade is predicted as follow. Okay, so we got the previous equation that y is equal 57.42 minus 0.186, and then the x, because this is we search for the UTS grade is equal to 10, so the x is 10, and then we got y equal to 57.42 minus 1.86. So we got the answer is y equals to 55.56. So for the interpretation, if the student score is 10 in their UTS, their predict y score will be approximately 55.56. So the second example is meanwhile the UTS grade is 85. So if the UTS 85, we just input into the equation that 57.42 minus 0.186 times 85, and then we get the result is 41.61. Okay, for the next one, it's for the correlation coefficient and the variable x and y, and then for that, it has simple. For the row, it's equal for 0.679641, and then for the row square, it's equal for 0.46192. So for the next, we go into the conclusion that we can conclude from the p square that value in this relation between the x and the y, or UTS and OHS, we is not strong enough because the value range from 0 to 1, or maybe 0, that is not related at all, but 1 is entered strongly related for this. And then the value which we got is 0.46192, and it doesn't even reach 0.5, and then we conclude that we can say it is not strongly related from all the equation here and all the substitute that we calculate to the end, right? So that's it, our presentation, and this is our end of presentation. We want to say thank you very much to you guys that you want to hear and want to watch our presentation, and then we are apologize if there is a wrong words or words that not pleasing. So that's it. See you next time.